So knowing where the base is lets you know where the triangle is turned and how it's shaped. So we always want to find the base first. Where are the base angles? So what are the name of our base angles here? Okay, J and G are base angles. What do we know about base angle measurements?
They're not even together.
No, that's not true. Base angles are the two angles in your triangle that are equal. So base angles sit on the base, and they are congruent to each other. So we've got to find the base first. Algebraically, the math's not that difficult. It's just a basic equation. But being able to set up the equation is the difficult part. You have to make sure that you know what pieces are equal and what pieces go together. All right, so we've got two base angles. We've got a base. Base angles are equal, so how should we set up this problem to solve? We know that they're equal.
3 plus x equals x plus 44.
Okay, 3x equals x plus 44. Now, we wouldn't know that these two angles are equal unless we knew where the base was. Base angles are always congruent. So we find the base angles, and then we can set them equal. So we subtract x to the other side. Remember, our goal is to get the x's together. 3x minus 1x is 2x. And when we divide by 2, what's 44 divided by 2? 22. Is that the end of the problem? No. What is the goal of this problem? Okay, we got x by itself, so are we done? Oh, there it is. This dang camera. All right. There we go. So what is the goal of our problem? Not JG.
EJ.
No, those are segment lengths. We want to find what? The measure of what angle? What angle does it ask at the top? Find the measure of angle what? G. So in this problem, it wants you to do more than just solve for x. Make sure that you're reading the question. It wants you to find the measure of angle G. How do we do that? How do we find the measure of angle G? What little expression is with G in our picture? You have to use your picture. What's the expression next to G? Okay, how do we use x plus 44 to find the measure of that angle? Someone's got to help Gabe out. How do I get the measure of G? I just need angle G. Find the measure of angle G. How do I find this angle right here? I've got x plus 44, but that's not my answer.
Yeah, 180 or something?
No, not 180. I've got x is 22, and I've got G is x plus 44. How do we know what the measure of G is? X equals 22, and the equation for G is x plus 44. So how can we use our x answer to help us up there with G? Nope. So looking at our picture, what equation is with G? Okay. Can I measure x plus 44? I don't know what that is. How do I use my x answer to help me right there? What does x equal? No, we just solved for it. What does x equal? 22. Good. How do we use 22 to help us up there where it says x plus 44? Add 44, yes. X is 22. This becomes 22 plus 44. So what is G?
66.
Okay. Oh my goodness. Okay, that took a little bit longer than we needed, but that's okay. We'll build those algebraic skills eventually. You've been doing this for a while. We've been adding up angles to equal 180, substituting. We'll blame it on the fact it's Monday.
What?
Yes, it is on today.
Okay, what I need you to do now is highlight the base in number 5 and see if you can set that problem up. I know, you can do it. See if you can highlight the base in number 5 and set it up. So where is the base? The top is the base. How did you know the top was the base? Yeah, it doesn't have the two congruent lines. That is the key. Where are the base angles? What letters? Okay, 6y. And this slant over here, what goes with that? What information? There you go. Yeah, they just drew that outside of the triangle because it doesn't fit inside the triangle. Yeah, but it'd be tiny. So how do we set this one up? We've got two base angles and nothing else. What do we do from here?
6y equals 8y minus 16.
Yeah, 6y equals 8y minus 16. These are equal to each other. They're base angles. The only time we're going to add stuff to equal 180 is when we have vertex angles with it. But for right now, we just have base angles, so there's nothing else for us to do. All right. So what should we do from here?
Subtract 8 from 6.
Okay, we want to move the 8. It is good practice to not move the 6 because you'd be left with nothing over there. And we want to be left with something. So I'm moving the 8y. So 6 minus 8y is what? Yeah, we got negative 2y. 8's cancel, bring down negative 16. What's next?
Divide by 2.
Divide by what kind of 2? Not just a 2. Yeah, negative 2. So what is our y value?
Y equals 8.
Positive 8. Is that the final answer? Is that the goal of our problem?
No.
No. What is the goal?
Find the n.
Yes, we're going to find n. It's telling you right up here. Okay, that's our goal. We've got to solve it. How do we do that? How do I solve for the value of n?
Back in.
Plug it back into which equation?
The one on the right side.
The right side is with P.
On the left side.
Okay, one on the left side. Remember, we want n. So we get 6 times 8, which is what?
48.
Yeah, we get 48. Now, if you did plug it into P, you would still get 48 because the base angles are the same. But to make sure that we understand where we should be substituting into, we want to make sure we're plugging into the correct variable. So find the base angles, build your equation off of that. So let's hop to the next one. What kind of triangle is number 6? Okay, yeah, it is a triangle. What kind of triangle?
Triangle.
What kind of triangle? Congruent triangles aren't a thing, but I think I know what you're talking about. So, okay, yes, all our angles are equal, so this is an equilateral. So this triangle is equilateral. I kind of threw them in there. What do we know about equilateral triangle sides?
Their sides are equal.
All the sides are equal. So every single side gets a bar. Here, here, and here. So equilateral, notice how all of the angles have curves. That means all of the angles are equal. Okay. How do we set up this problem to solve? Equilateral means all sides are equal. How do we solve this problem?
You strap on one side.
Okay, how do we find that one side? How do I set up my equation?
Here's that's only given. You're only like 4 numbers and anything else.
Okay, so what do I do with those numbers? I need an equation.
5y minus 6 equals 4y plus 12.
There you go. 5y minus 6 equals 4y plus 12. Equilateral means all the sides are equal. So if all the sides are equal, we set them equal to each other. And we recognize that that is an equilateral triangle because all the angles are also identical. Okay. So let's solve this one. What's next?
Work out the problem.
How do I do it though?
Subtract 6 from the right side, from the left side, take out the right.
You want to move the 6? Okay, let's add it.
Plus 6.
Yeah, there we go. So 5y equals 4y plus 12 plus 6 is 18. What's next?
Minus 4.
Yeah, there we go. We want to get that 4 to the other side. So 5y minus 4y is just 1y equals 18. So y is 18. Now, the goal of our problem is to solve for what?
OP.
OP. So how do I solve for OP?
You don't.
Yeah, we do.
It's 18.
No. We want to find the value of OP.
Multiply it by 4.
So OP is down here.
4.
Yeah. So 4 times 18 plus 12. So 4 times 18 plus 12 is 84. So the thing about these isosceles triangle problems is you want to make sure that you identify what you're trying to solve, classify the triangle. Okay. So now let's move on to word problems. We're going to do some word problems. Remember, a lot of these isosceles triangle problems, they're word problems. Okay. We've got to be able to draw the picture and analyze the picture. So let's try number 7. This is where vocabulary is going to be very helpful. The measure of each base angle of an isosceles triangle is 7 times the measure of the vertex angle. Find the measure of each angle in the triangle. So what kind of picture should we draw? What kind of triangle?
Hold up 11. Hold up 11.
Yeah, like number 11. So that's an isosceles triangle. So we want to draw an isosceles triangle. Usually when we draw isosceles triangles, the base is on the bottom. We put our legs here. That's just kind of how we like to draw them. When we think about them, we think of them sitting on the base. So I'm going to make the base here. And it says that the measure of each base angle is 7 times the measure of a vertex angle. So we need a variable to represent our vertex angle. Let's use a letter instead of a number. Did you say L?
Yes.
Okay. I'm going to make it a capital L so I don't think it's a 1. So we're going to use the letter L to represent our vertex angle. How can we represent 7 times the vertex angle? Yeah, we're going to use some numbers. So the base angles are 7 times the vertex angle. So 7 times what letter? Yeah, 7 times L. We've chosen L for our vertex angle. Remember, the base angles are 7 times that measure. So here and here, we put 7L, and make sure you're writing it capital so you don't accidentally think it's 71. So make sure that's capital. Now, how do we solve this problem? Okay, we did multiply by 7, but we've got 3 angles here. They should all add up to how much?
7.
What degree number? All those angles add up to a certain number.
180.
180. So you've got your two base angles. So 7L plus 7L plus your vertex angle, which is L, equals 180.
Got the answer.
Well, we got to solve for the variable first. Then it wants the measures of all our angles, so we're going to have to plug it back in. Okay, let's combine terms. How many L's do we have total?
3.
We got to add them though. I've got 7 L's here, plus another 7 L's, plus 1 L.
15.
So 7 plus 1 is 15. 15L equals 180.
We divided.
Yes.
It's full.
Okay, so we're going to divide both sides by 15. What did you get there? You got 12 too? All right. So L equals 12. However, that's not our final answer. Our final answer wants to know the measures of all of our angles. So we need the measure of our base angles. And we need the measure of the vertex angle. So which equation up there is our base angle? The bottom ones. So how do we solve for the measure of one of those bottom angles? The bottom angles are 7 times L. And I know L is 12. How do we use that to our advantage? We know L is 12. And we know that those bottom angles are 7 times L. So how can we solve for this? Yeah. So 7 times my angle is 12. So what is 7 times 12?
84.
84. Remember, those base angles, they're equal. So I don't actually have to solve for both of them. Once I know one of them, I know the other one. What's our vertex angle?
96.
No, remember, did you do 180 minus 84 to get 96?
Yes.
Yeah, but we can't do that. Remember, we have two base angles. Both of these are 84. So we're trying to find this vertex angle up here. It's just L. So what is L? It's the measurement of L. It's just 12. That's right here. L equals 12. Well, if the vertex angle is just L, L is 12. Those are a little tricky. The word problems are hard, but it's nothing you can't do. Okay, let's try the next one. We're doing lots of examples before we do some practice. So number 8. We got more equation building. It says the measure of each base angle of an isosceles triangle is 9 less than 4 times the measure of the vertex angle. Find the measure of each angle. So what kind of triangle should we draw? Good job, Nick. We're going to draw isosceles. Got my 2 equal legs, and my base is on the bottom. That's important. You want to find the base first. Once you find the base, it kind of helps you set up the rest of the equation. You've got to know where the base is first. Okay, to build the equation for base angle, we have to have a variable for our vertex angle. So I need a letter.
L.
You want L again? Okay, L it is. So to help us build the equation for our vertex angle, we have to have 9 less than 4 times L. So how do we do 4 times L? How do I write that? 4L. But I want 9 less than that. So what should I do with the 9? if I want 9 less than?
Yep.
Yeah, I'm going to subtract. Good job. So each of these little vertex angles is 4L minus 9. And I ran out of space. Let's see how small I can write this. There we go. That's as small as I got. How do we build the equation to solve for L?
4L minus 9, 4L minus
Well, if I set those equal, what about this top one?
leave it.
It's gotta be part of our problem. When I have 3 angles of a triangle, I need to use all 3 of those.
Exactly.
So how do I use all 3 of those angles?
Add it.
Add it to do what? When I add it, I have to have it equal something. So you're on the right track. How many degrees should all of those angles add up to equal?
180.
180. So 4L minus 9 plus 4L minus 9 plus L equals 180. So remember, these are your base angles. There's 2 of them. So take a second and solve for L. All right, so we should have combined 4L, 4L, and 1L for 9L. And then negative 9 plus negative 9 is negative 18. So where do we go from here? Yes, we want to add 18. So 9L equals how much?
198.
198. Divide by 9, so it's 198 divided by 9.
22.
22. Now, the goal of our problem is to find the measure of all our angles. So again, we need the base angle and our vertex angle.
22.
So the vertex angle is 22, good, because it's just L. So what's our base angle? That's 4 times L minus 9.
88.
Close. Remember, you've got to subtract 9 from it, right? It's 4L minus 9.
79.
There we go. So the base angles are 79. Okay, take a second. I want us to try 9, 10, and 11. We've done very similar problems like these, like 9, 10, and 11. I want us to try those 3, and then we will talk about number 12 together before we do our practice. 840. So we're doing 9, 10, and 11. All right, let's go ahead and go over it. So number 9. On number 9, you should get 13. Now, the base is highlighted yellow. However, the 3x minus 13 and 2x, those are not angles, they're sides. And those sides are called legs. Remember, the legs are equal. So I can just set 3x minus 13 equal to 2x because these are the legs of the triangle. So over here, I'm just going to write legs in parentheses because I should know that the legs are congruent. That's important. They're not going to add up to 180 degrees because they're legs. Sides of triangles don't have to add up to equal 180.
I have a question.
Yes.
Does that maybe go to the new on the board thing?
What?
Was that new Yoda thing? Is that
Yeah, it's baby Yoda. I'll make him. With melted
Tomato.
beads.
Oh.
Yeah, I made him with melted beads. All right, number 10. The base is YZ. Now, these are angles because notice how they have the degree symbol after them. That lets you know that they're angles. We know that Y was 3x. So the other angle, angle Z, also is 3x because those are base angles. So now I've got to add them all up. The important part here is that this box needs 90. So when I'm creating my equation, I have to include the 90 degree with it. So a mistake that we might have made, we can't do 3x plus 3x equals 180. We have to have 3 angles that add up to 180. So make sure you include the 90. Then we combined the 3x and the 3x right here to get 6x plus 90 equals 180. Subtract 90 and divide by 6 and we get 15. Number 11, we've got the base of AC. Again, we've got angles, not sides. So if we have angles, I want to look for my base angles, which are A and C. It is 12. So I'm going to combine 6x plus 6 plus another 6x plus 6 plus the vertex angle of 2 to equal 180. So when you combine, be careful. Make sure you're adding everything together. 6x plus 6x plus 2x gives us 14x. Then we combine the numbers. 6 plus 6 is 12. So be careful when you're combining. Make sure that you're combining everything correctly. So when we add all the x's, we get 14x. When we add 6 and 6, we get 12. Then we subtract 12 and divide by 14 to get an answer of 12. We're going to be doing plenty more practice with isosceles triangles. They're a very big part of this chapter. So the very last problem involves that perpendicular bisector theorem with the reflections and triangles. So I'm going to zoom into number 12. And basically, number 12 is just a lot of matching. Remember how we did this on the previous page? We have 2 equal triangles in this picture. So whenever you have one big isosceles triangle and you have a perpendicular bisector, this angle, or this triangle, is now exactly the same as this triangle. Everything about them is equal. So it's a lot of matching. So whenever we have perpendicular bisector cutting through a vertex angle, we have 2 identical triangles that have been created. Every single time you work with these kinds of problems, since it's a perpendicular bisector, what kind of angles are created down here at Y and Z? How many degrees is that if it's perpendicular? 90. So that means angle Y and angle Z are both 90. And that will be true every time you have a perpendicular bisector. So those are both 90. What other angles do we know? Or other variables?
40.
40? Okay, what other variable is 40? V. Remember, these are the same. You basically have to take this triangle and flip it over. So the triangles are identical. So V is also 40.
P is 30.
V is 30. Good job. Notice how these have 1 bar, making these the legs. So P is also 30.
Right, no E with X.
How do we find X?
By again, add up the E and stuff.
Yes, good job. To find X, we have this little tiny triangle right here. This little tiny triangle, I'm going to just draw it up here. We've got 40 degrees, 90 degrees, and something else. So those triangles have to add up to 180.
50.
Yes. So 40 plus 90 is 130. And then I subtract that from 180, and I get 50. So this is 50. So if X is 50, what other angle is 50? W. These are equal. It's a lot of matching. All of the triangles, that yellow triangle should have all of the same numbers as the green triangle because they are equal. Envision yourself flipping this triangle over this line of reflection, and this R would match up to S. They're kind of sandwiched together.